Okay. So, did I mention about the wine that I bought in Joshua Tree? Yeah? No? I went on a camping trip to Joshua Tree, so I went into the town, which is Yucca Valley. There's like a Big Lots there, something like that. And they had Santa Barbara wine for 99 cents a bottle. So it was 99 cents a bottle, I bought it. But when I brought it back to the campsite and tasted it, it tasted like vinegar. So the wine turned into vinegar. And so what had happened with the wine, you know, wines normally they contain sulfites. You know, sulfites. Well, what is sulfite anyway? Sulfite is SO3 ion. SO3 ion. What's the charge on SO3? Minus. Sulfites is used kind of loosely because sulfites can refer to sulfite like this or sulfur dioxide, SO2. They're both similar in certain chemical properties. You know why sulfites are present or sulfur dioxide is present? You know what it's used for? It's used as antioxidant. Antioxidant. Apparently what happened to my wine was that there's ethanol in the wine. And ethanol can be fully oxidized. If ethanol is fully oxidized, what does it get oxidized to? Like completely oxidize it. If I take my ethanol and completely oxidize it, it gets oxidized to, you know, what's it? Did I talk about ethanol? Did I talk about the accident that I had? The explosion? Yeah, okay. So ethanol is a pretty good reducer. And when you burn ethanol, what does it burn to? If you completely burn ethanol? CO2. Go to CO2. But you don't have to completely burn it. Let's say you partially oxidize it. Then you might form not CO2, but you might form carbon monoxide, or you might form soot. But do you know you could form other things as well, depending on the conditions. And so one of the things that we do is you could mildly oxidize it. And so if we use a mild oxidizer, you know, it's either chemically a mild oxidizer that is a weak oxidizer, or you might have a stronger oxidizer but in very low concentrations, like for example, very dilute. Then you could take the ethanol and you can oxidize it to something like this. You could oxidize it to CH3CHO. Do you know what this is called? This is called acetaldehyde. Acetaldehyde. And then we can take that acetaldehyde and mildly oxidize it a little bit further, and then we form this, CH3COOH. CH3COOH is acetic acid. Now, if I had this wine here, I wouldn't have minded if all the ethanol was completely oxidized. That is, if all the ethanol was oxidized to CO2. If all the ethanol was oxidized to CO2, then at least I would have had like, it would be like sparkling grape juice, you know, with CO2 bubbles, grapes. Sparkling grape juice, it wouldn't have any alcohol, that would have been okay. But, you know, I didn't get sparkling grape juice. You know what I got? I got vinegar. Vinegar was just acetic acid and water. So I couldn't drink it, so I used it to put out the fire. But what must have happened was the sulfites. You know, the sulfites did their duty, but what must have happened is too much air. You know, they're going to put some sulfites in here. Sulfites are going to be an antioxidant here. Sulfites are an antioxidant. Well, let's look at sulfites here as an example. You know, why would these two things be similar as antioxidants? Sulfur dioxide and sulfite. Well, the reason that they're similar is because of this. Oxygen's -2. Sulfur, what would the oxidation state on sulfur be here? Yeah, if oxygen's -2, then sulfur is +4. We can put those in parentheses here. And that means that would cancel out these two, and that would leave us with a net -2 charge. What is sulfur over here? +4. What is the maximum charge on sulfur? Maximum positive charge on sulfur? +6. And so both of these are capable of losing 2 more electrons, because when sulfite's oxidized, it's going to form sulfate. Well, you know, what must have happened here is this. You know, they don't want to put too much sulfites in here, because adding too much sulfites in there is going to alter the taste of the wine, right? So they just want to put enough. Well, how much is enough? Well, just enough to take care of any air leakage in here, because if air leaks in here, you know, it could oxidize. It can turn your ethanol into acetic acid. And so they put a little bit in here, but what must have happened is these corks weren't very good and lots of air got in there. And so lots of air is getting in here, then what that's going to do is it's going to eat up all the sulfites. When all the sulfites are eaten up and converted into sulfate, then the air is going to attack what's next. And so the antioxidant, the purpose of the antioxidant is the antioxidant should be easier to oxidize than ethanol. And so sulfite must be a better reducing agent than ethanol. Otherwise, the ethanol would have been oxidized and the sulfites would have just been spectators. We don't want that. You know, so if you're going to add sulfites, you want the sulfites to act as a sacrificial reducing agent, not the ethanol. So this is a topic of the next chapter. The topic of the next chapter is how much sulfite should you add? We can calculate that based on maybe some predictions, some guesswork there. But apparently not enough sulfite was added to mine. And so once all the sulfite was attacked and it was converted into sulfate, then the oxidizer, oxygen, is going to be looking for the next thing to oxidize. And not much air is leaking in there, so it's under mild conditions, mild oxidative conditions. And so in that case, the ethanol is the next best reducing agent, and that's going to get oxidized. It's going to get oxidized with acetaldehyde and acetic acid. Acetaldehyde will give you headaches. Same thing with acetic acid. If you drink acetic acid, it will give you headaches too. And in the body, it's interesting because you know, when you drink ethanol, ethanol is metabolized in your body. So if we look at ethanol metabolism, here, your body does this naturally. Your body is going to oxidize the ethanol into acetaldehyde, and eventually it's going to convert it into acetate or acetic acid. This is acetic acid, the formula here. It's not acetate. Acetate would be missing the hydrogen and have negative charge. And then that acetic acid or acetate goes into your regular metabolic cycle. Eventually, this ethanol is going to be converted into CO2, which you exhale, but not, you know, not after extracting all the energy possible out of it. And so your body normally is going to convert this into acetic acid. We just don't want it to do it prematurely in the bottle here. And so what we're going to do is we're going to do this. We're going to figure out the reaction that happened here. The reaction that happened here is this. Ethanol plus air yielded the vinegar. So you see the whole page. And so I want you to write the chemical equation. For the mild oxidation or partial oxidation of ethanol to acetic acid using the chart and skeleton redox method. So let me just get you started here. If we want to figure out the reaction that happened here, then normally when we do redox, we're going to inventory. And so when we inventory this, we're just going to keep the ingredients simple. In the inventory of this, we have ethanol, we have air, which would be O2, and we have water. Okay, so tell me what's the reaction here based on that inventory of those ingredients.